Hey everybody, John Wollwerth here. First of all, just wanted to thank everybody who has been watching this. We just hit 4,000 subscribers, which for me is a pretty big deal. Couldn't have done it without each and every one of you who has subscribed, so for all of you who did that, thanks. And for anybody who's watching this who hasn't, please go ahead and hit that subscribe button right now. So my wife Lynn and I have been working on this ambulance conversion behind me. We bought it in April. Bought it straight from the fire department, and we have been making it into a camper over time here. One of the things that was difficult for me to deal with when we were putting this together was putting in the electrical system. Now, if you have an ambulance conversion, you know that they come with 110 volt and 12 volt electrical systems already in them. But the issue is, in order to have power in an ambulance, you need to either be plugged into shore power, or you need to have the engine running and electricity coming off of the engine to the back box. And if you're planning on doing, an off-grid, off-road rig, this really isn't an option. You can't have a V8 diesel engine running all the time just so that you can have electricity back there. It's inefficient, it's noisy. I mean, there's so many reasons not to do that. I actually wasn't going to do this video initially because, I'm not an electrician, I'm not necessarily an expert on any of this stuff, but I have learned a lot through the process of putting this electrical system into the camper. And the thing that I found when I was doing my research was that a lot of the simple questions that I wanted to get answered really didn't get answered in the research I was doing. So I wanted to address a lot of that today. Also going to say that a lot of what I'm going to talk about here is just as applicable if you're doing a van build as an ambulance conversion. I'll also say that once you do have figured out what kind of a system you want to put in, you're going to want to do your research and find out what kind of fusing you're going to need, where you want those fuses, what size wiring you need. You want to do things right so that you're not that guy on the side of the highway with his ambulance build burning on the side of the road. Do not do that. So the first thing you need to ask yourself is, what am I planning on running on this electrical system? Because that's going to determine what your needs are going to be and what kind of a system you're going to have to put in here. Are you just planning on running a TV and some lights and maybe a couple of small things? Your system is going to look very different than mine. On the other hand, if you've got a system like mine where you're running a 12 volt air conditioner, you've got a refrigerator going, you've got interior lights, you might occasionally run an electric kettle, you've got a lot of high draw items, then your system is going to be a lot more robust than if you just got a very small need. I personally have 3 12 volt 100 amp hour lithium batteries, and that's what my battery system looks like. They're running in parallel for a total of 12 volts, 300 amp hours. For me, this is the absolute minimum that I would go with. And in fact, I'm probably going to upgrade, put at least another 100 amp hour battery in the future, because that 300 amp hours, it'll get the air conditioning through the night, but it's kind of getting down there by morning. So now, if you don't know the difference between parallel and series, if you run batteries in series, your voltage is going to be additive. So if you've got 3 12 volt batteries in series, you're going to end up with 36 volts. If you're running them in parallel, like I am, then you're going to add up the amp hours of your batteries. So I've got 300 amp hour batteries. The volts stay the same at 12 volts, but the amp hours is additive. So it becomes 300 amp hours. The jury is still out on these watt cycle batteries that I'm using. They came highly recommended, and 2 of them have worked flawlessly in the time I've had them. But the third battery, for some reason, I have had to warranty replace it twice, and I'm still waiting for a replacement to come back on that one. So the second thing you're going to have to figure out is, how am I going to charge those batteries? They don't charge themselves, so you got to figure out how that's going to happen. Now, there's basically 3 ways to do this. You can charge your batteries when you're plugged into shore power at a campground. You can charge them off the alternator when you're driving or when you've just got the engine running. And you can charge them off of solar. And you can choose 1, 2, or all 3 of these methods. Now, I have, for all intents and purposes, chosen 2 of them. I can charge the batteries when I'm driving down the road, running off the alternator, and I can also charge the batteries off of solar. And you can run more than one of these methods at once. So for instance, if I'm going down the road and the batteries are charging off the alternator and the sun is out, I can be charging off of both of those things at once, and those batteries will charge very, very quickly when both of those things are charging. Now, if you go this route, you're going to need two different kinds of battery chargers. You're going to need a 12 volt to 12 volt charger that charges off the alternator and puts the correct voltage into the batteries. And then you're also going to need a solar or an MPPT solar charger that will charge off of your solar panels and then put the correct voltage for that into the batteries as well. I'm going to start with the 12 volt to 12 volt charger because that is the simplest. While I went fairly cheap on some of the components I chose not to skimp on the chargers. You really want them to be reliable, you want them to function properly, and so I went with Victron components. I am not sponsored by them. They just build really good quality stuff, and that's why I decided to go with them. Both these components are Bluetooth, so you can get into the app and see how the charging is going, what the status of everything is. This is super helpful. You can even see what it's doing while you're going down the road if the Bluetooth will connect with it, if you're not too far away. You can even change all your settings within the Bluetooth app, which is great. One of the things to make sure of when you get these battery chargers is you need to make sure if you're running lithium batteries that they are compatible with lithium batteries, because lithium batteries charge differently than lead acid batteries. So you need to make sure of that. I chose lithium batteries because of their higher capacity, their lighter weight, their smaller size. There's a lot of advantages to running lithiums over lead acid batteries. But lithium batteries do charge differently than lead acid batteries, and that's why you need to make sure that your chargers are compatible with lithium batteries. The great thing about the 12 volt to 12 volt charger is that it detects when your engine is running. And this is super important because you do not want to have your starter battery in your vehicle charging your back batteries while the engine is not running. Otherwise, you're going to end up with a dead starter, and you're going to be stuck in the woods if that ends up happening. Both the 12 volt to 12 volt charger and the MPPT solar controller will detect when your batteries are full, and it will stop charging them if your batteries are full. This is also very important because if you have a charger that continues to charge your batteries when they're full, it's going to damage your batteries. Now, the solar system is a little more complicated. There's a lot of ways you can do things, so I'm going to talk in generalities here. The first thing is the solar panels. These I did go cheap on because you can buy used solar panels. Solar panels tend to keep their efficiency for years, so you can buy used ones for a fraction of the cost of a new one, but still have most of the capacity. There are a few things to know though. For the sake of simplicity, I'm going to talk in superlatives here and say that if you're getting multiple panels, get the same panels, matching panels, don't mix and match, because the lowest capacity panels can limit the other ones. And there's ways around this, but for the sake of saving you time and money, I'm not going to get into what the workarounds for those. I'm just going to say the easiest thing is to just get the same panels, matching panels. One other super important thing to know is that your solar panels are only at good efficiency when they are completely in the sun. If they are even partially blocked, even as much as 5 or 10% blocked by shade, whether it's branches or whether it's something on the roof of your camper, it's going to severely limit the amount of electricity that your solar panel is putting out. So that's something to keep in mind when you're putting things on the roof. I've seen people who have put a deck over part of the solar panel and then they wonder why it's literally putting no electricity out. So that's a very important thing to know. Now, there are two ways to set up your panels. Just like the batteries, you can set the solar panels up in series or you can set them up in parallel. There are advantages and disadvantages to each way of doing it, but for my purposes, I installed the panels in parallel for a couple of different reasons. The first is that if you have your panels in parallel, even if one panel is in the shade, the other panels will still function at full output. The other reason is that I was able to get away with a smaller solar MPPT controller this way. I actually have the capacity for more panels, but the limiting factor for me is actually my roof space. I'm able to fit 3 panels on my roof, and that's all I've got room for. So at peak capacity, I have 780 watts of solar panels on my roof, which for me is absolutely plenty. But how do you get the electricity from your solar panels? Well, that's where the MPPT controller comes in. It takes the electricity coming down from your solar panels, that can be any number of different voltages and amperages, and converts it to an amount that your batteries can handle to charge. There are different sizes of these controllers, but there are other videos out there that will help you figure out which one you need. If you're running your solar panels in parallel, you're going to need to fuse each of the panels individually. That way, if one of them shorts out, it doesn't blow all your panels. That's one important thing to know. You're also going to need a shutoff switch so that if you need to work on the system, you can shut off the electricity. You need to be careful with solar panels because if the sun is out, they are producing electricity. All right, so we've got our batteries set up and 2 different ways of charging them. Now we need to figure out how to run all the things off those batteries. So there's a couple ways you can do this. Some things you're going to be running are going to run off of 12 volts. For those, you're going to want to connect the 12-volt fuse block to the batteries. This way you can isolate and fuse each item you're running individually, and if something shorts out, you'll be able to locate the fuse. Some high-draw 12-volt items, like our air conditioner, have their own inline fuse and dedicated heavy-duty cable, so those are either going to come directly from the batteries or they will be routed through a bus bar. We're not going to run them through the 12-volt fuse box because it's for less heavy-duty things like lights and our 12-volt fridge, things like that. Finally, you have the things you're going to want to run off your 110 volt or 220 volt if you're in Europe household current. For this, you're going to need 12 volt to 110 volt inverter, or 220 if you're in Europe again. These come in different watt ratings, so the size of the one you need is going to depend on what you want to run with it. If you look at the bottom of most of your household appliances, it will tell you how many watts it draws. If you add up all the things you may want to run at the same time and then give yourself a 20% buffer, that should be about the size you need. I put a 3000 watt inverter in mine, which is total overkill, but for me the cost difference between it and the next size down was totally worth it. I can run an electric kettle and a toaster at the same time and it doesn't even hit the capacity, so there's plenty of capacity for me. So that's the basics of our electrical system. I'm going to put a link to someone else's video who went into a little bit more detail in regards to fusing and wiring and things like that. So when you hit that point where you're ready to put your system together and you figured out what you want to do, please watch that video and it'll give you a lot of useful information with making sure you do things safely. If you found this video helpful, please give us a thumbs up and let us know if you have comments or questions. And also follow us to see more about our ambulance build and some of the other things we've been up to and some of our travels. So till next time, this is John Wollwerth and thanks for watching.